Hi ladies, we're going to go through some questions from 4G, which is finding the equation of a line. The questions I chose are throughout the textbook, but I'm not doing every single question. So if you do come across one that you don't understand, please let me know and I'll go through it with you. Okay, so let's get started because I like to keep these, these videos very short, but I say that and then they go for about 18 minutes. So I'm aiming for 10 minutes. So let's see how we go. All right, question number 2, determine the equation of the following straight lines. Okay, so we can see here, goes through the x-axis at -3 and the y-axis at 3. So you can say, all right, the 2 points, so remember you only need 2 points to draw a line, but also to find the equation of the line. So I'm just going to write down those two, and I don't know why my cursor's there, sorry about that. -3, 0 is here, and this point here is 0, 3. Now, there's several ways you can do this. I will show you the way that you can apply to any line, but there's actually a shorter way you can do it for this one. So I'll do the general way first, and then I'll show you the shorter way. Okay, so first of all, let's find the gradient. So the gradient is just the difference in, is rise over run. So the difference in your y values over the difference in your x values. So there is a formula, and I'm not going to write it out now because I'm just mindful of the space I have. But remember, label your points x1, y1, x2, y2. The reason they're labeled like that is because it's x, y, and this is point 1. So 1, 1, 2, 2. Okay. And then your gradient is just the difference in your y. So 3 minus 0 over the difference in your x. So 0 minus, and just be careful with that negative because we're going to have 2 negatives there. So 3 minus 0 is 3. 0 minus -3 is 3. So your gradient is 1. Now, there's, from this point, whoops, I'm just trying to scroll down. From this point, you need to put it into the equation. So there are 2 ways you can do that as well. So you can use this formula, which I've taught you before, and I'll show you the other way. And it's always good in maths. There's often more than one way of doing things. And some people will say, oh, you have to do it this way. But I think the way that suits you is always the better way. So I'm going to show you this way. Some people would prefer this. So your values of y1 and x1 come from here. So you could use either point. Okay, I'm going to use x1, y1. So we're going to have y minus 0. My gradient is m, so I'm going to put that in, and then x minus x1, which is -3. Now your x and y just stays the same. The only thing we're substituting in is m, x1, and y1. Okay, so y minus 0 is just y, and then we expand this bracket. So 1 times x is x, and then your 2 negatives makes that a +3. So 1 times 3 is 3. So there's your gradient. There's your equation. What you could have done also from this point, okay, so we found our gradient. You could substitute it straight into the equation y equals mx plus c. So y and x are either of these 2 points, so you can use either one. I used -3, 0 before, so I'm going to use that again, but either one is fine. Your gradient is 1. Your value of x is -3, and then you've got plus c. So in this one, we're basically finding the value of c, which is our y-intercept. So just going to do the 1 times -3, bring that 3 over, so c is equal to 3. And then we substitute it into our equation. Sorry, I'm just going to pause for it. Okay, I don't know whether you could see, but my emails were coming up. So now we're just substituting our y-intercept and our gradient into the equation. So it's y equals 1x plus 3. And we don't usually write 1x, so it's just going to be x plus 3. So you can see you can do it this way, we get that answer, or you can do it this way, we get the same answer. Okay, so whatever method suits you. Some people prefer this method because it gives you the equation straight away, but others like this one because they think it's not as complicated, but that's probably a personal choice. You get your y-intercept, but then you also have to substitute it back into the equation. All right, so if I just scroll back here, now remember at the start, before I started doing these questions, I did say there was, for these ones in particular, there was a quicker way. So I can see straight off that my y-intercept is here. Okay, so your y-intercept, remember, we use the letter C. So there's 3, and then you can also do your gradient. So to go from this point here up to this point, we say, how many are we going up by? We're going up by 1, 2, 3, and we're going across 1, 2, 3. So you can see going up 3 and across 3. So your gradient is 3 over 3, which is 1, and then you can substitute it into y equals mx plus c to get your equation. So what I'm going to do, just because this question here, I don't have much space, I'm going to do it this quicker way, okay? So again, my y-intercept is clearly labelled, and I can work out my gradient. So how many do I go up by? I go up by 2, okay, because we're going from -2 up to 0. Oops. And then how many did we go across by? We went across 1. So my gradient is 2. So your equation is y equals 2x minus 2. Okay, let's scroll along. Okay, and then question B, you could have done it the working out way that I did before. Okay, but sometimes on your graph, when you can see things, it's a little bit easier. Okay, so this one here, you can do straight from your graph. So I've got a y-intercept there of 3. So C is equal to 3. And your gradient, okay, so how many did I go up by? I went up 1, 2, 3. So you can see I went up from here up to 3. And how many did I go across? 1, 2, 3, 4. So there's a 4 over to 0. You don't have to do those squiggly lines. You might be able to do that without having to do that. All right, so your equation is y equals the gradient 3 over 4 x, that was a terrible x, sorry, plus 3. Now 3/4 x you can also write as 3x on 4 plus 3. Okay, so just remember they're the same thing. All right, this question here. Now, if you're wondering why I didn't do the working out like I did before, because I'm pretty sure there are questions coming up that don't that require us to do that working out. So let's do these ones the easier way. Okay, so this one here, we're going down this time. So we're going down 1, 2, 3. Okay, so we're going from 3 down to 0. So that's -3. And then we're going across 4, 1, 2, 3, 4. There's no scale on there, but I'm kind of pretending there is. Okay, so we've got -3/4 x plus 3, or you can write that as -3x on 4 plus 3. All right, so let's move on to the next question. So this one here, we can't, unless we drew the graph, you would have to actually do a little bit more working out. So similar to how I did that very first question. So we know m is equal to 3, so our gradient is 3. And we've got this point here, 1, 8. Okay, and I'm going to write that again just because I can. All right, so I'm going to show you both methods. Oh, that's a terrible Y, sorry. So you can use this rule. Okay, so if you're using that, we're going to label this one x1, y1. And just substituting in those values now. So y1 is 8. My gradient is 3. And remember, x and y just stay there, but we're just substituting in for x1. So we've got 1. And then let's just tidy things up. 3 times x is 3x. 3 times -1, -3. We want to get y by itself, so let's add 8 to both sides. So that disappears. So we've got y equals 3x. -3 plus 8 is plus 5. Okay, so that's that way. And I'm going to scroll just to give me a bit more space. If you wanted to use the other method, remember we're just substituting it into the equation y equals mx plus c, where x and y is just a point. So we've got 8 equals 3 times 1 plus c. So 8 equals 3 plus c. So c is going to be 5. So when I substitute in c and your gradient, which is up here, into our equation, we've got y equals 3x plus 5. So the same thing. All right, so you choose which method suits you. I'm just going to, my personal preference is usually the second method, just because that's how I always have done it since high school, but I do like this method too. So I'm just going to finish off doing B just quickly, and this method is a little bit quicker. So what have we got? -5, -2 times 2 plus c, -5, -2 times 2 is -4, and then we've got 4 over there, so that's going to be -1. Just make sure I'm not going too quickly. And then we've got y equals -2x minus 1. Okay, so there's our equation. All right, scrolling on now to question 6. A line has a gradient of -2 and a y-intercept of 5. Okay, so let's just write question 6 here. So my equation, remember in the form y equals mx plus c, it's given me both m and c. So I can put them straight in. So m is -2 and c is 5. Now remember your x-intercept is when y equals 0. Okay, it's because it crosses the axis at y equals 0. So we've got y equals -2 times 0 plus 5. Oh, what am I doing? Sorry, I was finding the y-intercept and it's already given it to me. Sorry. Oh gosh, 0, let's go slower, -2x plus 5. So I accidentally before substituted the wrong variable. So I did x instead of y. Okay, so we've got, let's take that 5 over, subtract 5 from both sides. So I've got -5, that's -2x, divide both sides by -2. So your x-intercept is -5 over -2, which is 5 on 2. Now you can leave it like that as a mixed number. There's nothing wrong with that. You can put it as a improper fraction or say it's 2.5. That's okay. All right, if you are leaving it as a fraction or a mixed number, an improper fraction, put it as its simplified form. Okay, it's a good habit to get into for the later years. Okay, let's have a look at question 7. A line passes through the points -1 and -2 and 3, 3. Find its x and y intercept. So this question is a little bit more complicated. That's why I put it in there. So let's find the gradient first. So the gradient difference in your y's, so 3 minus -2 over 3 minus -1. So we've got 3 plus 2 is 5, 3 plus 1 is 4, so that's your gradient. And sometimes when we've got a bit of working out, it's a good idea to put a square around. Okay, and now we have to get our equation. So I'm going to get my y-intercept just by substituting things into y equals mx plus c. So you can use either -1, -2, or 3, 3. I don't know which one is easier off the top of my head. Sometimes it's a pain in the butt to work with negative numbers, so I might just deal with 3, 3. So we've got 3 equals 5 on 4 times 3 plus c. Okay, so 5 times 3 is 15 on 4 plus c. And c is equal to, I'm going to have to just scroll, give myself a bit more space. C is equal to 3, subtracting that from both sides. And we can't leave it like that, so let's put have the same common denominator. So 3 can be rewritten as 12 over 4 minus 15 over 4. So your y-intercept is going to be 12 minus 15, which is negative 3. So negative 3 on 4. So my equation, and I'm going to put a square around that because that is my y-intercept. And I forgot, oh, so there, no, I didn't forget, I can just see it there. So my gradient was 5 on 4. And my y-intercept, now I'm going to have to scroll, get a bit more space. To find your x-intercept, we let y equal 0. So we've got 0 equals 5 on 4x minus 3 on 4. Okay, put the 3 on 4 over there. I can get rid of those 4's just by multiplying both sides by 4. Oops, that was supposed to be an equal sign. So x is equal to 3 on 5. So there's your x-intercept. So my gradient, I don't think I did work out the gradient, did I? Can't remember. It's 5 on 4. Your y-intercept is here, negative 3 on 4. And your x-intercept, lastly, is 3 on 5. Quite a difficult question working with fractions, but if you take your time, and hopefully I haven't made any mistakes, but if you take your time, often you're more likely to get it right. If you rush, you can make mistakes. All right, girls, bye.